Welcome. In this video, we are going to discuss on joint distributions. That is, here if you see as it is said in the slide, we are considering two random variables x and y. Okay. As of now, we are assuming both of these random variables are discrete. The joint distribution function of x and y is given as f of xy, which is nothing but probability that x smaller than or equals x and y smaller than or equals y for real numbers x and y, and the marginal distribution of x. No, supposing we have this joint distribution, now that we are looking for the distribution of x alone, that is denoted as x capital F of x, which is nothing but probability of x smaller than or equals x, and it can also be denoted as f of x comma infinity, which means we are taking all possible values of y and x is restricted to this limit. In a similar way, we can define the marginal distribution of y as well. Now, this thing I said it is for discrete random variables, not I'm sorry about it. It can be applied for both discrete and continuous random variables. Now we will move to the case when these variables are discrete random variables. In that case, we will have a joint probability mass function, which is given as f of xy, which is defined as probability that x is taking the value small x and y is taking the value small y. And we know that all this possibility are greater than or equal 0, which means the probability should be a non-negative quantity. And if you make the sum of all possible things, okay, that is summation, here are all x, this is in simpler terms summation under x and summation under y of all this things is 1, or you can interchange the summation as well. There is no harm. In both the cases we get it as equal to 1, that is the total probability is 1. Now that with this joint probability mass function, if you are trying to find out the marginal probability mass function of x, just sum it to all possible y's. Okay, we are fixing x and all possible y we are taking, and this is known as marginal probability mass function of x. In a similar way, we can define the probability mass function marginal PMF of y. Okay, now that here we have some problem. Okay, the first one is x and y are two random variables with this mass function. Now we are asked to find out the value of k that is appearing in this. Okay, let us see how do we calculate it. Okay, so in one side let me have x and the other side let me have y. X is taking three possible values 0, 1 and 2, and y is taking two possible values. Okay, it is said that k multiplied with 2x plus y. So here 2x 0 plus y is 1, so it is simply k, right? And here it is 2, okay, here it is 2 plus 1, which is 3, so it is 3k, and here it is 4 plus 1, so it is 5k, and here it is 0 plus 2, so 2k, and again here 2 plus 2 which is 4k, and here it is 4 plus 2 6, so 6k, right? So this is the mass function of the given thing. Okay, here I am going to perform something extra as well. If I add all these things, I would get what? So if I add all these things, I would get 9k here, and here it is 12k. Okay, and if I add here, it is 3k and it is 7k and it is 11k. Whether I add this one or this one, in total what I am getting is 21k. So summation under x, summation under y of all this xy is 21k, which is 1. That is the total probability. Therefore k should be equal to 1 upon 21. So we have found the value of k. Now, which is not asked in this question, but still let us try to find out the density function. So in this density function we have what? X, and fx of x, isn't it? Okay, x is taking the values what? 0, 1, 2. First, let me find out the mass function, marginal PMF of x. So x is taking all these three values. That is 3k, 7k and 11k. So you know the value of k. 3 upon 21, 7 upon 21 and 11 upon 21. This is the marginal PMF of x. In a similar way, for y, we have this thing. Okay, y is taking only two values. So 9 upon 21 and 12 upon 21. Even here, if you see summation fx of x under all possible x gives you 1. Similarly, summation under y, fy of y gives you 1. Okay. Now that if you need to calculate the uh, distribution, marginal distribution, then what? Fx of x. So it is 0, 1 and 2. So 0 means it is simply 3 upon 21. 1 means you will have to add these two values. So that sums to 10 upon 21. 2 means it is 21 upon 21, that is 1. In a similar way, you can calculate for y. Okay. Now coming to the next question. An urn contains 2 white, 3 black and 4 red balls. Two balls are drawn randomly and let x be the number of white balls and y be the number of black balls. Write the joint PMF of x and y. Okay, so only we are going to choose two balls, right? So out of these two balls, what are the possibilities we have? Both can be white, okay, white and white, and both can be black as well, and both can be red as well, and one white and one black. This can be chosen in two ways. Okay, so the first may be white and the second may be white. There are two options. Then one shall be white and the other shall be red, and one shall be blue and other shall be red. So the combinations. Okay, now that these are the possibilities, for these possibilities we will have to see. Okay, now how are we going to do it? So white and number of white balls and y be the number of black balls. So out of this, if you see, there is a chance that you do not choose any white ball at all. There is a chance that you choose only one white ball. There is a chance that you choose two white balls. The same for black balls, isn't it? Okay. Now you need to see out of these things how many possibilities are there for this, there for this, and there for this, and you will have to fill it up. Okay. After filling this up, you will have to, yeah, here you are asked to find out only the joint PMF. Okay. That's it. Thank you.